It's just after 11:30 p.m. Eastern Time on Friday, March 6th, and you're looking at a live view of Cape Canaveral's Space Launch Complex 40, where Falcon 9 is about to launch a Dragon spacecraft. Liftoff is targeted for 11:50 p.m. Eastern Time, or 4:50 Coordinated Universal Time. I'm Kate Tice, a Senior Program Reliability Engineer here at SpaceX. It's great to be here with you to cover our 20th Commercial Resupply Mission to the International Space Station for NASA. Tonight's mission is a special one as we bid farewell to the first version of our Dragon vehicle, which made its debut in 2012 as the first private spacecraft in history to visit the International Space Station. To this day, Dragon is the only spacecraft currently flying that's capable of transporting significant amounts of cargo to and from Earth. Beginning with CRS-21, we are excited to be flying an upgraded version of Dragon spacecraft that will not only be capable of flying cargo, but also people. For tonight's mission, we're targeting an instantaneous launch window. If we're delayed, scrubbed, or abort for any reason, we will move to our backup launch date, which is currently scheduled for tomorrow at 11:27 p.m. Eastern Time. We're just about to hit the T-minus 13-minute mark and counting, with all systems currently go at both our Cape Canaveral Mission Control Center and our headquarter Mission Control Center here in Hawthorne, California. So let's take a closer look at today's Falcon 9 and Dragon spacecraft out on the pad.
My name is Jessie Anderson, and I'm a lead manufacturing engineer here at SpaceX. Tonight, we will be delivering approximately 4,500 pounds of cargo to the space station, including critical materials to support dozens of science and research investigations that will occur on board our orbiting laboratory. We'll go a little bit more into detail on some of that research later on in tonight's webcast. This will be SpaceX's 5th launch this year, and we'll be launching a flight-proven Dragon spacecraft, which flew twice before, back on CRS-10 in 2017 and CRS-16 in 2018. Dragon was designed from the beginning to be reused, so this will be our 3rd mission flying the same vehicle for the 3rd time to the International Space Station. This marks our 9th mission reflying Dragon. We'll also be flying a reused booster, which supported our last CRS mission back in December. To date, we've had 80 successful launches of Falcon 9, and 30 out of that 80 were on reflown boosters, which is almost half of those launches. Tonight, we will be bringing Falcon 9 back to land at Landing Zone 1 in Cape Canaveral for use on future missions. For those keeping count, if we successfully land Falcon 9 tonight, this will mark our 50th booster landing. Above the first stage is the second stage, which has a single Merlin vacuum, or what we call MVAC engine, which ignites after the first stage separates. The second stage is what will carry Dragon to its intended orbit, allowing the spacecraft to eventually rendezvous with the space station. With that, let's check in with Kate to get a status update on tonight's mission.
It's T-minus 11 minutes almost, and the SpaceX team is working no significant issues. The go, no-go poll was conducted at T-minus 38 minutes, and propellant loading began shortly thereafter at T-minus 35 minutes. At this point, RP1 is completely loaded on stage 2 and nearly complete on stage 1. Liquid oxygen loading is underway on both stages and will complete at T-minus 2 minutes to launch. We're also loading helium gas into both stages. Falcon 9 uses helium as a pressurant to backfill the propellant tanks as both LOX and RP1 are consumed by the Merlin engines during ascent. Dragon also began its startup sequence at T-minus 35 minutes when it coordinated timing with Falcon 9. It's currently undergoing vehicle health checks, with the next big step at T-minus 8 minutes when Dragon transitions over to internal battery power. The range is ready to support. Now, we have had our eyes on those winds going on this evening, but within the last 20 minutes, they have been trending in the right direction, so looking good there for now. As with the launch team, Falcon 9, Dragon, and Range are reporting green, and at T-minus 10 minutes on the dot, all systems are currently go.
Tonight's mission will be the last for this version of our Dragon vehicle, which began making trips to the space station back in 2012, becoming the first privately developed spacecraft to do so. Since Dragon's first flight, the spacecraft has spent 520 days attached to the International Space Station. That's almost a year and a half. To date, Dragon has made a total of 20 trips to the station, flying over 95,000 pounds of cargo and returning over 76,000 pounds of cargo back to Earth. In its 8 years of service, Dragon has also delivered some really cool and vital scientific experiments to the orbiting laboratory, and tonight's mission is no different. Dragon will be carrying dozens of research payloads to the space station, including the research in the National Laboratory, operated by the Center for the Advancement of Science in Space, or CASIS. There are more than 20 payloads included on this mission, sponsored by the National Lab. The National Lab payloads represent a diverse group of research investigations, all of which are intended to benefit life here on Earth. Let's take a look at some of the groundbreaking research from CASIS that will be aboard the CRS-20 mission.
SpaceX's first Commercial Resupply Services mission of 2020 is absolutely loaded with research to benefit life on Earth. This marks SpaceX's 20th resupply mission to the space station. So what's on this mission? Let's take a sneak peek. Adidas, the shoe and apparel giant, will be sending its proprietary Boost shoe technology to station for evaluation. With this experiment, Adidas will observe the flow of different sized foam particles of microgravity to improve product design for athletes around the world. Delta Faucet will investigate water droplet formation on the space station to enhance the company's H2O kinetic showerhead technology. This technology takes an innovative approach to water conservation by controlling the size and speed of water droplets so the water pressure feels the same even though the showerhead is dispensing less water. This study will explore ways to better control water droplets to further enhance the H2O kinetic technology. In addition, both the National Science Foundation and the National Institutes of Health are funding multiple investigations on this mission. The National Science Foundation is supporting an investigation examining colloids and suspensions in microgravity to advance 3D printing technology in space-based environments. While NCATS, a branch of the National Institutes of Health, continues to build on the Tissue Chips in Space program by funding 2 investigations seeking new ways to study human disease and test potential drugs. Lastly, several projects flying on this mission are from startups that have received funding through the Mass Challenge Technology in Space Prize awarded by Boeing and the ISS National Lab. These projects are looking at drug development, technology for medical diagnostics, and new drug delivery methods to improve patient care on Earth. There's a lot going on with this mission, and this is just a quick snapshot of some of the investigations launching on SpaceX CRS-20. To get an idea about all ISS National Lab sponsored payloads on this mission, I encourage you to visit our webpage at issnationallab.org.
This is just a small sample of the dozens of research experiments that Dragon will take up to the space station. You can follow @space_station on Twitter for more information on the exciting microgravity research happening on the orbiting lab. We are currently under contract with NASA to resupply the space station through 2024 as a part of our second Commercial Resupply Services contract award. These missions will use the next version of Dragon, which can fly both cargo and people. In fact, this past week we celebrated the 1-year anniversary of Demo 1, which marked the first time a privately developed crew-capable spacecraft visited the space station. Flying NASA astronauts and helping keep the space station fully operational is a top priority for SpaceX, and our first mission with NASA astronauts is coming up later this year. On top of that, we have more exciting news. SpaceX has signed a contract with Axiom Space to fly 4 Axiom crew members on a Crew Dragon flight to and from the International Space Station. Axiom will provide NASA-certified crew training and operational management for the mission, which is set to launch as soon as the second half of 2020. This will be history's first fully private human spaceflight to the space station and the first in a series of missions that will provide unprecedented access to the orbiting laboratory. All of these missions, whether for NASA astronauts, international astronauts, or for the regular citizen, are all key steps towards making human race multiplanetary.
We're currently just under the T-minute 5-minute mark and counting down to an 11:50 p.m. Eastern launch to the International Space Station. In these last few minutes, Falcon 9 is performing final health checks on its primary communications, avionics, and propulsion systems in preparation for flight. As mentioned earlier, we're currently loading liquid oxygen into the propellant tanks. Fuel loading for both Stage 1 and Stage 2 is now complete. At the T-minus 7-minute mark, we began engine chilling. That's when we inject a small amount of super chilled liquid oxygen to prepare the 9 M1D engine turbopumps for full prop flow during flight. You might hear the call out that engines are sufficiently chilled in later in the countdown. Checkouts of the second stage thrust vector control actuators, or TVCAs as you might hear them called, are now underway. You'll often hear people refer to this as an engine wiggle test. This is when we move the thrust nozzle slightly to make sure that the guidance hardware is go for flight. First stage engines also wiggle, but they do that just seconds before ignition. At T-minus 1 minute, Falcon 9 flight computers will enter startup mode and guide the rocket through the rest of the countdown. The SpaceX launch director gives the go for launch call at T-minus 45 seconds. Finally, a few seconds before liftoff, the engines are ignited. At T0, the rocket is released from the hold down clamps for liftoff, after which the strongback, which is the white truss section that you see there behind the rocket, that will fully retract away, clearing the way for F9's ascent. Dragon is performing its own final health checkouts to make sure all of its primary systems are ready for its rendezvous with the space station. Range remains green for launch. Winds are still, we're keeping an eye on those, currently showing at 18 miles per hour from the north-northwest, but still within our limits. So with that, everything is green for takeoff. Just under the 3-minute mark before launch, let's listen into the nets for the last few minutes of terminal count.
And Stage 2 LOX load is closed out. Vehicle's in startup.
Dragon is in startup.
LD, go for launch.
T-minus 30 seconds. T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition, liftoff. Carpe diem, Dragon 1.
Vehicle is Switching downrange. Now 1 deep pause.
Power and telemetry nominal.
At T plus 45 seconds, Falcon 9 has cleared the towers, and the final Dragon 1 flight is underway. Everything looking nominal
Falcon
for stage
9 is
1.
supersonic.
We heard the call out that the vehicle is supersonic.
Vehicle is experiencing maximum dynamic pressure.
There we heard the call out for max Q. Coming up next, there are 5 events that will be happening in rapid succession. Main engine cutoff, or as you'll see in the event tracker on the bottom of your screen, MECO. Then stage separation, second engine start, or SES-1, followed by a boost back burn of the first stage and Dragon nose cone deploy. Main engine cutoff, for MECO, is where all 9 M1D engines on first stage will shut down. This is immediately followed by stage separation, where the first and second stages will separate. A few seconds later, MVAC, or the M Merlin vacuum engine on the second stage, will ignite and begin to boost Dragon to low Earth orbit.
Impact shield started.
So again, MECO, stage sep, SES-1, all happening in quick succession. Let's tune in.
Stage separation confirmed.
And there on the right-hand side of your screen, and by the cheers in the crowd behind me, we have visual confirmation of second engine start as that warm glow begins to build around the MVAC nozzle. On the left-hand side of your screen, we have an amazing visual of the first stage as it is performing its boost back burn. Now, this is the first of 3 maneuvers that the first stage will be performing. As Jesse mentioned earlier, we will be landing back at landing zone 1 on the coast of Florida at Cape Canaveral. So the first stage has to completely reorient itself and head back west. It was flying east, now it's going to flip around, head back west towards the Cape during this boost back burn, which should be ending in 5 seconds. MVAC is looking good. Everything nominal with our temperature and power
Stage
readings
1
there.
boost back shut down.
And we can see on the left-hand side of our screen that the boost back burn has completed. Second stage looking good as Dragon is on its way to the International Space Station.
Vehicle is on a nominal trajectory.
Acquisition of signal in Bermuda.
In order to make its way back to landing zone 1, the first stage executes a series of 3 burns. The first of which you just saw is the boost back burn, and as Kate mentioned, this is meant to slow the rocket down and orient it for re-entry. It also helps Falcon 9 laterally return to the landing zone. Then shortly after this first burn is initiated, the grid fins, which are located near the top of the first stage, are deployed to help guide the rocket during descent. We're not showing a live view of the first stage right now because it's pretty dark, so you can't see it. But what you're seeing on your screen is the second stage continuing on its way to its targeted orbit. So then following the boost back burn, Falcon 9 executes its re-entry burn to slow itself down before hitting the dense part of the atmosphere. And then the last of the 3 burns is the landing burn, which begins just before touchdown, and that's to slow the vehicle down rapidly right before landing. So far, second stage is still looking good. it's T plus 5 minutes, and the second stage is taking Dragon to its targeted orbit. We've had an on-time liftoff just a few minutes ago, and we're just about a minute away from that second burn on the first stage, that entry burn. Again, if we do land our first stage tonight, it will be our 50th landing. Second stage
Vehicle continues to follow a nominal trajectory.
And there's that call out for nominal trajectory. If you're just now joining us, it's T plus 6 minutes, and we're about 30 seconds away from the first stage entry burn, which will then be followed by the landing burn and landing of the first stage on our landing zone 1 in Cape Canaveral. So you can see on your left-hand screen, this is a view from the first stage. You can see Earth with all the lights lighting up the ground. Once that entry burn begins, we should be able to see that light up that screen on the left side.
Stage 1, entry burn, startup.
And there it is, entry burn has started. This burn will last about 20 seconds long. Again, as I mentioned earlier, there's those grid fins that you can see on your left-hand screen near the top of the first stage. That's guiding the vehicle to the landing zone. And there's that shutdown of that entry burn. So we're just about 40 seconds away or so from the landing burn start. The landing burn will last about 30 seconds before the vehicle touches down. Second stage is still looking nominal. And it is a bit dark since it is nighttime over there in Cape Canaveral,
Stage
but
1, entry train
we should
sonic.
be able to get a live view of this landing.
Stage 1, landing burn, startup.
And there's that landing burn starting.
Stage 1, landing leg deploy.
And the Falcon has landed for the 50th time in SpaceX history. What an amazing live view all the way to touchdown.
Stage 1, nominal landing confirmed.
What an awesome view of our first stage for the 50th time. Congratulations to the entire SpaceX team for another successful landing. This marks our 50th successful first stage recovery, which is an important part of our commitment to vehicle reusability.
A lot of excitement as we hit yet another milestone here. There's a big crowd in Mission Control behind me, as you probably could tell. So at this point, second stage is performing nominally. We had an on-time liftoff from Cape Canaveral, and among all the excitement, we did get the call out for a second engine cutoff. So at this point, we're waiting to hear confirmation of good orbit. And we do have that confirmation. So good orbit has been confirmed, and at this point, second stage has one last major task to perform, and that's to command separation of Dragon, which should be happening in less than a minute from now. Actually, hopefully just in a couple of seconds now that I'm looking at the timeline. We should have video here. There we can see a view into the Dragon trunk. That is the unpressurized section. Successfully deploying away from second stage. That unpressurized cargo is stuff that is able to be exposed to the vacuum of space. Everything that cannot endure such an environment, we pack into the pressurized section. So coming up in about 2 minutes, we should have solar array deployment. As Jesse mentioned previously, Dragon is carrying tons of cargo to the International Space Station on this mission. A small portion of the cargo represents supplies for the astronauts, things like food and clothing. But most of the cargo represents science going up to the space station. The International Space Station serves as the world's leading laboratory for cutting-edge research and technology development that will enable human and robotic exploration of destinations beyond low Earth orbit, including the Moon and even Mars. There on your screen we have a view of the second stage. That was the MVAC engine that has been shut down, obviously, as you can see. As Dragon is moving further away from our second stage, keep in mind that this is just the beginning of its 2-day journey to the space station. Like I said, the next big event we'll have is solar array deployment coming up in under a minute. We'll also have guidance navigation control, or GNC, door opening, but unfortunately we won't see the GNC door opening live, but we will be able to catch solar panel deployment, which is what we're waiting to see on the left-hand side of your screen. Right now the solar arrays are compacted, folded up along the side of the Dragon trunk, and that's the view that we see there on the left. As I've mentioned a couple times tonight, this is the final cargo resupply mission to the International Space Station using the first version of our Dragon vehicle. The upgraded version that we're using next has a different trunk design than the one that we're currently looking at. In the new version, oh, there we have visual confirmation of deployment of the solar arrays. As Dragon stretches its wings for the very last time, I'd like to congratulate the SpaceX and NASA teams that have designed, built, tested, and supported this spacecraft over the last decade. Your hard work has paved the way for the first Crew Dragon flight with NASA astronauts later this year.
Primed and Northwesters report ready for firing.
Dragon is now on its way to the space station. Very exciting day, as you can hear the crowd behind me. Over the next couple of days, Dragon will perform a series of orbital height adjust maneuvers with its Draco engines until it's within a few kilometers of the International Space Station. Then Dragon will establish a communications link with the space station. And then we will perform a series of checks on the vehicle. And when both NASA and SpaceX are ready, we'll initiate a slow approach to the International Space Station, pausing at several checkpoints along the way to ensure crew's safety. When Dragon is within 10 meters of the station, the astronauts aboard will capture Dragon using the station's robotic Canada arm in a process called berthing. Finally, Mission Control in Houston will send commands from the ground to the station's robotic arm to rotate and install Dragon to the Harmony module. Dragon will remain at the space station until the beginning of April before returning to Earth with research and return cargo.
We had an on-time liftoff from Cape Canaveral Space Launch Complex 40, a beautiful ascent and return of our first stage for the 50th time, landed back. We landed the Falcon 9 for the 50th time, and as you just saw on your screen, a beautiful stretching of the last solar array deployment of the first version of Dragon. Dragon's arrival, capture, and installation to the space station will be streamed live on March 9th, starting at 5:30 a.m. Eastern on NASA TV. Dragon will spend about 4 weeks attached to the space station before returning to Earth with cargo and research.
That's going to end our live launch coverage, but we'll be posting mission updates on NASA and SpaceX's social media accounts. We want to give a big thanks to the Range and the Federal Aviation Administration for their support today. And finally, thank all of you, the viewers, for joining us for such an exciting mission tonight. Until next time, have a great weekend.